So now let's talk about vector. This one or vector. So now let's start with the addition and the subtraction before we move to the multiplication. Now addition of vector, addition and subtraction of vectors of vector. Are we together? Vector quantity, these are quantity with magnitude and direction, right? And in this case, when we are talking of magnitude, when we are talking of direction, we can have the I direction, the J direction, the K direction, like a graph. So the x-axis is known as I. This is positive I. This is negative I. This is positive J. The y-axis is known as J. This is negative J. Negative J. So we can have one more axis. Are we together? Which this one is known as the x, y, z. This one is known as the z. And this can be what? Can have negative k. We call it k now. The z is the k. And we can have our positive k. So that is if it is in 3 dimension, 3D, if it's in 3D. So we have IJK, which can be written as XYZ, where I is X, Y is J, and Z is K. Take note of that. So now addition of vector. If I have vector A equals to 2I plus 3J, then I have vector B equals to I plus 4J plus 3K. Now I want to find VA plus VB. So I want to add vector A to vector B. These are the basic, but let's just start with that. 2I plus I, this one give us 3I. 3J plus 4J, this one give us 7J. Now this one does not have K, then you can assume that it is what? Is 0K, right? Even though they don't give you as 0, but you put 0 there since it doesn't have 0K plus 3K plus 3K. So this is the vector. Like this is the vector component. What I mean by vector component is it must be in form of ij or ij and k, depending on how many dimensions you are talking about. Are we together? So now, how many direction rather? So now this is the addition of vector A and vector B in their vector component. But what if we want to find the magnitude? Magnitude of VA plus what? VB is going to give us square root. What's the coefficient of I here? 3. You square the 3. Plus, what's the coefficient of J here? 7. You square the 7. What's the coefficient of K here? 3. You square the 3. So this gives us root 3 square 9 plus 9, 18. 7 square 49. 49 plus 18. That gives us what? 67. So the magnitude is root 67 units. Do we get that? 67 units. Assuming it's in velocity, we have root 67 meter per second. But we are not told what quantity the vector is. That's that for that. Same thing goes with subtraction. If we want to find VA minus VB, we still do it this minus this, this minus this, this minus this. Still normal thing. Are we together? So whether VB minus VA or VA minus V, I'm coming. There's something I wanted to say. Okay, sorry. Yeah, that's it. So let's just, okay. Yeah, so that's the magnitude. Now, without wasting much of our time, let's just quickly move to the multiplication of vector. Multiplication of vector. Multiplication of vectors. Hello, are we there? Now, when we are talking of multiplication of vectors, we have 3 different ways of multiplying vector. The first one, you can have vector times scalar. The answer is always vector. A vector quantity multiplied by a scalar quantity always give a vector quantity. Take note of that. Do we get? It will always produce a vector quantity. And whenever you have a vector quantity, you are using what? Cross product. Cross product or cross multiplication. Product is also multiplication. So cross multiplication or cross product, they are the same thing. The second one, we have vector times vector. Vector times vector is possible to produce a scalar quantity. So if vector times vector give you a scalar quantity, are we together? Here we are going to have what? What I mean here is not cross product. I just mean normal multiplication and not, because we also represent this cross product with this sign. So what I'm doing here is just normal multiplication. Like if you multiply a vector by a scalar to get a, you will always get a vector. So you are going to use cross product. So that means this multiplication here is cross. If you multiply a vector by a vector and it give you scalar, you are going to use dot multiplication, dot product. So which means the multiplication you'll be using here will change to dot. But I'm just expressing mathematically that I'm multiplying, because cross product is different from dot product, even though both are product, both are multiplication. So if you're also multiplying a vector by a vector, it's possible to also give a vector. It depends. So this one, if it gives a vector, you also use what? Cross product. So vector times scalar will always give a vector. So vector times vector can either give a vector or a scalar. Whenever your whenever your result is vector, you use cross product. Whenever your result is scalar, you use dot product. Now let's talk about cross products now. Okay, sorry, let's start with dot product. So examples of vector times vector that give a scalar is force times displacement. Force times displacement. Force is a vector, displacement is also a vector. But the answer is what? To equals to what? Work done. And work done is the scalar quantity. So in this case, what, for instance, if I say a body is pushed with a force of 20 Newton and move a distance in the direction of that force, a distance of 5 meter, like the displacement now, equals to what? 5 meter. Find the work done. Now because work done is a scalar quantity, so we are going to use dot product. Oh sorry, let me write it in form of vector. Maybe the force equals to 2I plus 7J Newton, and the displacement equals to what? 3I minus J meter. So find the work done. Now we are going to use dot product. So F dot S equals to 2I plus 7J dot 3I minus J. Is that clear? So now dot product is that you multiply this by this, then you add this, is it 2I times 2 times 3I is 6I square. Whenever you are doing a dot product, I times I, once the direction are the same, for a dot product, I times I equals to 1. So you may not need to multiply everything, just pick the coefficient alone. 3 times 2 times 3, that's 6, plus multiply all the j together. The coefficient of j is 7, the coefficient of j is minus 1. 7 times minus 1, minus 7, right? So 6 plus minus 7, that's what? Minus 1. So your final answer now is, since work done is in joule, you have minus 1 joule. You have minus 1 joule. Is that clear? That means the work done is negative, like is how can I put it now? The work done is, there's an English I want to use. The work done on the body now. Is it the work done on the body, or the work done is just negative? There's an English I want to use there, but it's not coming. So we have minus 1 joule as our work done. So that's how to use dot products. Now let's check another question on dot product before we move to cross product. Now if we have vector A to give us 2I plus 3k plus 3j plus 3j minus 4k, and we have vector B equals to 7I minus j plus 2k, then find the magnitude of VA dot VB. That is, you first find the dot product, then you now, okay, sorry. Since it's dot product, the answer is going to give us magnitude direct. Yeah, there is no direction in dot product because dot product is a scalar quantity. So we are going to have magnitude alone. So now let's dot vector A with what? Vector B. So here now, VA dot B is going to give us, now multiply this by this, the I by the I, the coefficient of I by the I. 2 times 7, we have 14. 3 times minus 1, the coefficient of J is minus 1. 3 times minus 1, we have minus 3. Minus 4 times 2, we have minus 8. So this gives us 14 minus 11. So answer is what? 3, let's call it 3 units now. Why did I call it 3 units? We are not given the kind of quantity they are, whether this can be force, this can be displacement. Assuming it's force and displacement, and we have joules here. So, but because we are not given, so you can just add units, whatever it is. So that's our VA dot VB. Now for cross product, for instance, if I give you VA equals to a vector A equals to 2I plus, we still have some formulas I'm still going to write if time permit us, because we still have a lot of things under this. We can't finish everything in one video. We do another video whereby we continue this multiplication of vector. 2I plus 2j, then I have vector B equals to I plus j. Now I'm now asked to find VA cross VB. Find VA cross VB. Now, what am I going to do now? I want to do cross product now. Now, there's a method we use, we known as matrix method. So if you want to use the matrix method, this must be in 3 dimension. Like, the direction must be 3. It must include k for you to be able to use matrix method. Otherwise, you can't use the matrix method. But the question does not include k. So you can add since there's no k there, you can add the 0k plus 0k. It has not changed the question. So this is still 0, you get this back. This is 0, you get this back. So now your VA cross VB, we give you now, write ijk, I plus j plus k. Now what's the coefficient of I here? 2. What's the coefficient of I here? 1. What's the coefficient of j here? 2. Sorry, there's no plus. What's the coefficient of j here? 1. What's the coefficient of k here? Is 0. What's the coefficient of k here? Is 0. Now hope we all remember matrix method. Now this guy give you I into, this one go like this, go like this, it remains 2 0 1 0. 2 0 1 0 minus j. You know matrix is plus minus plus minus. Minus j. J comes like this, it goes like this, goes like this. What do we have left? 2 1 0 0. 2 1 0 0. Are we together? So plus k. K comes like this, it goes like this. What do we have left? 2 2 1 1. So here we have 2 2 1 1. Then let's find the determinant first before you open the bracket. So this one now give us equals to I. 2 times 0 minus 0 times 1. That's how to find determinant. 2 times 0 minus 2 times 0 is 0 minus 0 times 1 is 0 minus j. 2 times 0. I'm trying to check something. dr 2020. Right, 2020. 2 times 0 is 0 minus 0 times 1 is 0 plus k. 2 times 1 2 minus 2 times 1 2. Are we together? So what do we have here left? We have 0i minus 0j. 2 minus 2 is 0 plus 0k. It's possible another time we don't have 0 0 0. So assuming it's not 0 0 0, that's the answer. But since everything is 0 0 0, that means our cross product equals to what? The cross product of the two vector equals to what? 0. Are we together? So that's that for that. Take note of that. Now, if cross product, actually, there is no k there. We're only given 2 direction, right? So if the cross product, we only had this so that we can apply this method. Now, if the cross product equals to 0, what does it mean? If cross product equals to 0, this is it. Since the original question is in 2 direction, so now, if VA cross VB equals to 0, now what does it mean? It means that VA is perpendicular to VB. Why? Because for cross product, the formula is A cross B equals to magnitude of A multiplied by magnitude of A multiplied by magnitude of B cos theta. Am I right? No, sorry. That means equals to, it's not perpendicular, I'm coming. This is dot product. Cross product is sin theta. Yeah, cross product is sin theta. Sorry about that. So that means if VA cross VB equals to 0, then that means VA is parallel, not perpendicular, it's parallel to VB. They are in the same direction. So if they are in the same direction, that means the angle between them is what? Is 0. Isn't it? The angle between them is 0. So now, A cross B equals to, since sine 0 is 0, the 0 multiplied by whatever I said is also 0. So A cross B equals to 0 when angle is 0. This is the formula. A cross B equals to AB sine theta. So if we get A cross B to be 0, that means the angle is parallel. So if the vector is parallel to each other, if they are parallel, that means the angle between them is 0. So sine 0, I'm just showing us how they are being verified. So that's that for that. Thanks for watching. See you in the next vector class. We are going to do a lot. We are going to do more on this. So that's that about that. Always add direction. Sorry about that. Except if it's a scalar quantity, but this is vector. So now, thanks for watching. Don't forget to like and subscribe and share the video with your friends too.